Alright, let's do cubic function, which is the very last thing in function other than inverse and so forth. Okay. You have, let's say you have as a standard equation y equals to a x cubed plus bx squared plus is it cx plus 2. Okay, so d in this case would be your y-intercept. So it's gonna be your y-intercept as straightforward like that. Okay, meaning in a situation of a graph like this, okay, so it means that your y-intercept is gonna, but that's your graph is gonna cut at d. All right, if you are given an equation and you are interpreting a graph where the graph has cut the y-intercept at point A or whatever point, and you are asked to determine that point, and you're also given a graph that if it's, let's say this is point A, they want you to determine point A, you take exactly that value that is represented by d, in that case the value without x. Okay. Also what you have to notice here is the fact that you have two turning points because a cubic function. Okay, and a is just telling you about the direction as always. If the graph would increase, if the graph is increasing, it means that it's gonna start by curving down and curving up. If this is negative, it means that the graph will start by curving up, then curve down. Alright, so that's the use of A. Let's try to draw this graph. Okay. What do we need to this from this graph to plot a graph? From this equation to plot a graph, we need the turning points, two turning points, and we need x-intercept, that's, and the y-intercept. So we need three things: one, turning points; two, intercepts. Three, okay, intercept include y-intercept and x-intercept. Yeah, it's just those two. Okay, let's start by giving ourselves an example here. Let's say y is equals to x to the power 3 plus 2x squared minus 4x plus 9. Okay, that means our y-intercept is 9. Let's say this is 9. So our graph has to cut at 9, right? But our graph has to have this shape, meaning first curve down and curve up, right? Okay. What is gonna be our turning point? Let's start by our turning points, right? So our turning point is gonna be the derivative of this graph. Would know those who are doing physics, but at this point, this is a turning point, and this point, there's no movement. There's no movement at this point, meaning your velocity is at 0. And your velocity is just, if you would agree, it's simple. A gradient, because your velocity, change in velocity, is given by change in displacement over change in time. Okay, so that is simple. That is simple a gradient. That is simple gradient. So your gradient here has to be 0 and here has to be 0. What does that mean? It means that we need to first derive a gradient of this graph. A gradient of this graph will be a first derivative, meaning it's gonna be f prime, which is the first derivative, equals to 3x squared plus this times this 4x, subtract 1, hence your exponent are keeping on decreasing, right? And this time this is still is minus 4. 1 minus 1 is 0, x to the power 0 is 1. 1 times 4 is 4. Okay, so we have that as our gradient. Okay, so we are saying this must be 0. Our gradient at the turning point is 0, so this has to be 0 to determine the x-intercept at the turning point. So we have 0 here equals to x squared plus 4x minus 4. So we're gonna use our we can factorize if we can. Let me try to see. Okay, we can factorize this, or we can use a quadratic equation where we have x equals to minus b plus or minus root is 4ab. Has been a very long time since I last saw this. What is it? I think it's b squared 4ac, yeah, all over 2a, yeah. So you can still use this formula. For simplicity purpose, let's say our x-intercepts of the turning point, our x values of the turning point turn out to be x equals to negative 2 or x equals to let's say 3. Okay, those are our turning point. That means we have 3 here, we have negative 2 here. Okay, I hope you'll be able to do your algebra here, but I'm worried about time and the length of the video, right? And let's also assume that the corresponding y values, if we substitute this negative 2 here, we get y equals to, remember it's gonna start up, so let's assume we get y equals to it has to be above this point, so let's say it's 10. This is 10, and if you substitute this one, x, to the original equation, let's say you get y equals to, it has to be negative because it's gonna be curving up. So let's say in this case, in this particular case, we got negative 5. Okay, negative 5. So this is our turning point. So let's say this is our negative 5. Okay, and let's say this is our 10. 10 is here. So the turning point need to be here. The first turning point need to be here, and the second turning point need to be here. Okay, so those are the point of the turning point. This graph would have to cut here x-axis at this point, and it will also cut x-axis at this point and also at that point. All right, let's assume that our x-intercept, where we were determining x-intercept by letting this be 0, our x3 coordinate was firstly -4 or +1 or +5. Okay, let's say this is 5, this is 1, and this is -4. Okay. That means the graph will be like this. The graph will be like this. And it's gonna go down like this and turns here and goes up. So that is our graph. Okay. This can be A, B, C, D. This can be E, F. They can ask you a distance between this and this. You simply use the coordinate here and the coordinate here. Use distance formula. They can ask you a distance between here and this. Remember, they are on the same straight line. It's going to be this value here, which is 1, minus that one, which is 5. So the distance would be 4 if they're asking for that. So I don't want you to lose those easy marks, okay? If they ask you a distance between this and this, A to F, is gonna be 4 units to here and 5 units to here, which is 9 units. You just get your 3 marks, which is 9 units. I don't want you to lose those marks. If they ask you the distance from here to here, it's just 9 units, as you can see. If they ask you a distance from B to E, it's gonna be a coordinate here and a coordinate here, and use a distance formula. Okay, I don't want you to lose those easy marks. Okay, what could be the range of this nature? What could be the range of this graph? Okay, the graph has to turn here and the graph has to turn here. The graph is only existing here on this portion because there's a ceiling here. It cannot exceed here, and there's a limit here. The graph would never go beyond its turning points, its 2 turning points. Okay, so the range in this case would be this value here. What is here? It's -5. What is here is 10. So the range in this case would be y, because y touches here at -5. Y is greater than or equals to -5, or y it's less than or equals to 10, because this graph can touches 10, but it cannot go beyond 10. So it's limited to -5 and 10. So that would be your solution. Okay, you can go as below -10 up to the extent of -5. So that would be your answer for range. What about domain? Domain is endless because this graph can move to whatever value on the negative side and to whatever value on the positive side. That means your x in this case is an element of all real numbers. So that is your solution. Okay. They can ask you, but what is the value? Okay. For which values of x's? Okay, let me leave that part. I'll deal with that part at a separate section because it's more advanced. And even the issue of gradient, I'll deal with that part as well at a separate session. I think that is it for cubic function, except for complexity. I will deal with complexity at a later stage. Right. Will be combined.